In this unit, we took a closer look at the requirements analysis stage of the life cycle. Mistakes made during this stage tend to have a multiplier effect, so it becomes important to have methods for formally verifying and documenting requirements. We then moved over to the end products of requirements analysis themselves, the data model and the process model. We saw that these are notationally simple techniques that allow you to create simple but expressive models of business data and business processes. These techniques themselves may be simple, but the act of modeling is a fairly subjective activity and is learned only over a period of time. Any questions?
The notation that you showed us seemed insufficient. For example, the data model showed that a course could have at most an indefinite number of students, but does not specify how many. I'm sure a real system will have to take into consideration the capacity of the classroom.
Well, you are right. You could in fact use more notation on the data model to convey more information. But think for a moment about how the data model is going to be used during design. There are a very simple set of rules which can map a data model onto a third normal form database design. For these rules to be usable, you need a certain minimal amount of notation in the data model. And it's this minimal set which any data modeling method must use. That's the set which you just saw. You could in fact put more notation on the data model, but that wouldn't directly contribute to database design.
If I show a process called compute grades in the process model, what exactly the process does might still not be absolutely clear to everyone.
Well, you express what goes on inside a process by writing what is called a process specification. This sounds a bit like a program specification. And in fact, if you were to look at a process specification, at first sight, it would in fact look like a program specification. The key difference is that a process specification is a statement of business essence and contains nothing about design or implementation constraints.
How do I use the data and the process models to create a design?
Well, the data model is intended to map onto a database design, and the process model is intended to map onto a program design. The key word here is intended. People have found that process models are not very easy to map onto program designs. So process modeling remains largely a tool for requirement specification. On the other hand, a data model is very easy to map onto a database design. There are simple rules which will map a given data model to a database design in third normal form. These rules are so simple and straightforward that any tool for systems analysis and design will do it for you at just a click of a button.
Are data and process modeling only of historical interest now that object-oriented methods are catching on?
Well, not quite. Object-oriented methods impact the way we do design very significantly, but they don't significantly impact the way we do requirements analysis. Though there are over a score object-oriented methods in the marketplace today, you'll find that for the most part, object-oriented analysis is very similar to data modeling and process modeling, which means that the modeling lessons that we have learned in the past continue to stand us in good stead.